Now, in order to understand solution equilibrium, what we're going to do is remember that when something is unsaturated, that's not equilibrium. Unsaturated means that you can still get stuff to dissolve. So notice I'm going to use this kind of arrow if it's unsaturated, because if I put in a solid, it dissolves one way. Only when it's saturated do I start thinking this is equilibrium. Okay? Everything else in the reaction looks the same. So if it's equilibrium, well, it seems to me there's some terms that we could use. There's a K value to be learned. But what kind of K value? Kp? No, there's no pressure. Kc? We're going to go one better. We're going to invent our very own word for a K. This isn't just the K of any random molarity. This is a K based off the solubility of a saturated solution. We call it Ksp. And Ksp is specifically for solubility product constants, for saturated solutions. Guys, would you please tell me again our three-word definition of any K? Products over reactants. Our new way is going to be
Products.
just products, that's right. Why just products?
Reactions are solid.
Bingo, that's a great way of putting it, Eric. That reactant, this expression will be how we write it every single time, and every single time that reactant is solid. Solids don't have a molarity. So the ions do, things that are aqueous have molarity, but solids do not. And since we've said this is the form we're going to use, products over reactants, heck no. Products over one, or just products, that's fine. But for us, Ksp is always going to be the molarity of the products. Notice 2 ions of A make it A squared, 1 ion of B make it B squared. Those are the solubility of the two products, because the reactant is always solid. Yes?
1 ion is B squared.
Say it again.
1 ion is B. Wait.
The ion of A would be squared. The ion of B would be the power of 1, but I tend to leave that off sometimes because if the coefficient is 2 to 1. Did I misspeak?
He said B squared.
Well, you're alert, obviously, and I set that up as a trap to see if anyone was paying attention. And obviously I factored up. I'm sorry. I factored up. I just can't. I can't. But. So when we take a look at solution solubility equilibrium, I just want to do kind of a comparison with how we can kind of take a look at these things, okay? When I think about ionic compounds, I have in the past thought of them as being soluble and insoluble, either or. I don't know how to tell this to you, but I've not been entirely honest with you. What shocking. I haven't been truthful. By the way, if any man ever tells that to you, you just turn around and start walking away. But not now.
Why is that surprising?
We have always introduced this idea that solubility is either soluble or insoluble, and we had some mnemonic device that helped us with that rule. That mnemonic device was NAGSAG, right, where we said soluble, insoluble. As it turns out, the degree to which something is soluble is really up for discussion. Let's take a soluble salt we all know of, sodium chloride. If I really make it as concentrated as I can, if I make it saturated, it's about 5 molarity. That's pretty high at room temperature. And I think to myself, that means it's at equilibrium, but if this is 5 molarity sodium chloride, that means it's 5 molarity sodium and 5 molarity chloride, right? The Ksp then would be the products only, where the products only, or we ignore the reactant, would be 5 molarity times 5 molarity equal to 25. That's a big number, and I say it's not listed. What do I mean exactly? Well, you picked up that sheet at the blue table, didn't you? That blue sheet? Would you take a look at that for me? Huh? Let's go back there. This is a photocopy from your textbook, and I want you to do a couple things with it. On the first page, I want you to put your name. And I want you to put down on that first page, chapter 16-KSP. Now, it has a backside as well, but that backside isn't for us right now. That'll be chapter 15 when we use that. So you need it, but you just don't need it for a couple of weeks. Chapter 16 right now. This KSP is 25. Look through those lists. Look at the numbers. Do you see anything as big as 25? Nothing close. Everything there has an exponent 10 to the negative something. So what we notice is things with high KSP are not listed. Things that we're calling soluble are not there. A very small KSP implies something else. A very small KSP implies you have an insoluble compound. What you're seeing is a chart of chemicals that we've called, up until this point, insoluble. And up to this point, we thought that meant it will not dissolve. Not now, not ever. But as it turns out, they do dissolve. Maybe only a little bit, but everything dissolves a little. How much? Well, there is lithium fluoride, which is technically slightly soluble. Not highly soluble, not insoluble, but slightly soluble. I can make it 0.062 molarity at room temperature at the most. It will dissolve the same way, except I didn't have room for the expression. Lithium fluoride forms lithium ions and fluoride ions, meaning that its KSP would be lithium times fluoride. If the molarity is 0.062, then that means the lithium molarity is 0.062, and the fluoride molarity is 0.062. You'll multiply those together, because after all, P means product, right? Multiply product, 0.0038. Now, we didn't find sodium chloride on the blue sheet. Could you find lithium fluoride on the blue sheet? Look for it. Is it there?
Yeah.
Notice they're listed alphabetically by the first element. There's a lithium fluoride there, and its number, does it match?
Yes.
So that's great. We have charts of known K values, and that known K value matches this KSP. Compare its number to the other numbers, though. Is this kind of in the middle, kind of on the big side, kind of on the small side? Yeah, it's one of the biggest KSPs in the whole sheet of paper. It's soluble, so you'd think it wouldn't be there, but it's only barely soluble. Compare that to something that we thought was insoluble, silver chloride. We used to think there's a chemical that will not dissolve. Matter of fact, we just did an experiment where silver chloride was the precipitate, not dissolving. However, it does dissolve. Saturated, forgot my D. Saturated silver chloride has a whopping huge molarity of 5.3 times 10 to the negative 5 molarity. It's a very tiny, tiny little number. Likewise, we think that means silver chloride forms silver plus chloride. KSP is silver times chloride. KSP is this being both the silver and the chloride ions squared together, giving us a 1.8 times 10 to the negative 10.